3-5, day 1, pre-lesson. Hang in there. This has a lot of little details that you gotta know them all. Don't know a few of them, understand all of them. No pressure. Just rewind this, listen to it again. If something throws you for a little loop, there's some rules coming at you, and there's multiple ways of kind of attacking these problems. Feel free to use whatever technique works best for you, but here we go. So, starts out with kind of a review question. It says, what are the zeros of this function? Like, wait a minute, this is review. So step 1, oh, I forgot to read the instruction. Then graph/sketch. That means it doesn't have to be perfect, but it should be pretty accurate, the function. And you're supposed to do this without a calculator. Now, which means decimals, but you can use it to check your work. So don't be afraid to check your work with technology, but you're supposed to be able to understand the concept prior to just banging it out on your calculator. So I know it's a bit of a like, come on, really? But you're going to be expected to do this without a calculator on a quiz and a test, potentially SAT, ACT. So you got to know the process. Here we go. Pre-lesson. So step 1, find the zeros, plot. So technically we have a graph. There's your typical XY axis, but you might want to get started by just thinking about your x-axis. So you can use this to get started, you can use this to get started, it's up to you. But to find my zeros, I say, hey, what value can I put in there to make that the whole thing 0? That'd be 0. So 0 is one of my zeros. Now if I just use some random chart here, there it is, there's my 0. I can see that that's 0. This one I'd have to label it. This would be a 4. So I'd have to go out here somewhere, remember, sketch. So I'd go out here to about 4, label it. I know the graph's going to go through here somehow. And then I could go out 1, 2, 3, 4. A little bit more accurate. And then -3. So over here, I'd go right about there, -3. Here, 1, 2, 3. And there we go. So that's step 1. Now, step 2, what are we going to do for step 2? Here's where it's going to get a little bit dicey, okay? The book is going to show you, if you read the book, to plug in things from here, like you could plug in -4, and here, and here, and here, see where it goes, and that's fine. Plug in something between 0 and -3, like -1 or -2, and plug it in, see where it goes. And then plug something in here, like a 2, see where it goes. And then plug in something like 5 or 6 or 7, and just see where it goes. All of that will work fine, but there's a shortcut, and that's what I want to show you right now. So if I look at it, step 2, I want to ask myself a question. Now, I'm going to write this down so I don't waste video time. Okay, so next question. You're going to ask yourself really 2 parts. If you look at this, you're going to ask yourself, hey, if I actually multiplied this all out, like I multiplied this times this, got my answer, and then multiplied by that, would my degree of the polynomial be odd or even? So now all this talk about what degree is the polynomial is going to be very significant. So all of a sudden you're like, whoa, glad I learned that. Or if I didn't learn it, I got to learn it now. Here's a shortcut. If I just look at this, there's a 1 there, there's a 1 there, and there's a 1 there. If I only look at this, this, and this, I would say, you know what, x to the first times x to the first times x to the first. If I look at that, it's x times x times x. Well, there's a 1, a 1, a 1. What is that? That's x cubed. So I know it's an odd degree, and that's huge because the end behavior is the same if that's a 3, a 5, a 7, a 9. So if I go back to what I've learned, y equals x cubed, is going to look like this. So what I'm talking about is it's going to go like this, the end behavior, and that's also true only if the leading coefficient is positive. So that's the next question. Is the leading coefficient positive or negative? Well, once again, if I only focus on that x, that x, ignore the -4, ignore the 3, because if I multiplied this all out, I would get 1x cubed. The shortcut method is look at this, look at this, look at this, and there's no negatives out in front either. So I know if I was to multiply that all out without even doing it, my leading coefficient is positive and it's odd, which tells me my end behavior is going to be like this. So I call this the Oreo cookie. You get that little chocolate wafer, and then we're going to worry about the stuff in the middle, double stuff, single stuff, later. So with that in mind, I know the end behavior is going to be like this. So we'll talk about that in a minute. Now, if that's a 2, we know it's a parabola, so the end behavior would be like this. But it's not a 2, it's a 3. So I'm going to focus on the cubic, and I go, wait a minute, I know from here it's going to go up, and here it's going to go down, just from previous lessons that we've learned and a little bit of common sense. Now, if I want to do that over here, it's the same thing. And now we got to fill in the double stuff or single stuff. Here we go. All right, let me pause this. Okay, now I know this stuff is new to you, but these are rules that are true for all graphs. So you can sink your teeth into this, but remember, this is our first example in our pre-lesson. Second example is going to open up your eyes to a little bit more of what I'm saying. But let's read this. Step 3. We're going to be concerned about what happens exactly at the zeros. So something could happen. It could come down here and bounce off and go up, or it could go through and then back up. Again, you could cheat with a Desmos, but that's not the goal of this lesson at all. Here's the rule. If the power of, I'm just going to keep it general, each part. What do you mean each part? That part, this part, that part. So I've listed them here. I got x, which is actually x to the first, so that's odd. I got x minus 4 right here. There's an invisible 1 there, so that's a 1, that's odd. Same thing goes with x plus 3. That's a 1 power, odd. So according to the rule, on all 3 of these zeros, so at -3, at 4, and 0, it's going to pass through. Now, if I use a little common sense, that means it's going to go through, and then it's got to go up, and go through, and then come down. All right, step 4 is coming. Okay, so I would call this a bad sketch, because we got one more step. Now we're going to sketch it, which means, it's good enough. But here's the thing. We're going to try to find out where that point is exactly, to figure out how accurate our bad sketch was. How do you do that? A little common sense. What's halfway between 0 and 4? 2. So we're going to let x equal 2, plug it in. We're going to find out exactly where that point is. It should be negative. And then we're also going to plug in this halfway point. Unfortunately, the halfway point is -1.5. So we're going to let x be that as well. Now I'm not going to burn up all this time. I'm going to show my work. I'm going to erase a little bit. I'm going to plug that stuff in here and see what my y value is after doing so. This is the last step. Okay, so I've done my work. I plugged in 2, the halfway point, to find out how low it is beneath the graph. And as you can see, if I plug it in, I get -20, which I knew it was down. We just didn't know it was how far down. So this graph, we're going to finish it. It's going to go way down and then come back up. So we know that that is actually 2, -20. And the question is, how high does it go? Well, when I plug this negative in, look at it, I got a negative times a negative, which is positive. And then this is a positive thing, so it's a positive times a positive, so I end up with positive 12.375. Obviously, we're not going to be that accurate, but it's going to go up to 12, not quite far down as 20, so I'm just going to put it right here and say that, and there it is. So I graphed it with great accuracy. Is it perfect? No. Tripped on the cord. But you can check with decimals now, and it's okay. Okay? One more coming. All right, this example is going to go a little bit faster. So here's a brand new function. Here's the same sort of scenario. Step one, find the zeros. Well, if I put a 0 in there, that's a 0. -4 would work there, so 1, 2, 3, 4. -4, 0. And 1 would work there, so I'm going to make that my 1 right there. Okay, so that's 1, 0. There's my zeros. So next question. Is this an odd or even function? Again, shortcut. X to the 4th, don't worry about that -1, times x, there's an invisible 1 there, and that x, there's an invisible 1 there. If I multiply that all out, I'd get x to the 6th. So this is an even degreed function, which has its own rules, and the leading coefficient, if I focus on just this, and just this, and I look here, there's no negatives involved. So that's going to be a positive leading coefficient. So the one we know about that's even, our kind of our parent function for n behaviors, y equals x squared, which looks like this. And if I take out all this middle stuff, because this is x to the 6th, so that's going to be kind of wavy, but the reality is the ends are going to be like a parabola. The rules don't change. So I can start here and go up. I can start here and go up. It's a little bit of a cheat. Let's keep going. So now, there's the Oreo cookie chocolate wafers. Now we're going to move into the cream, okay? Double stuff or single. So if the power of a part, so here's a part, and a part, is even, see this is different, it bounces off the 0. So I got a 1, that's odd. I got a 1, that's odd. So we know it's going to pass through those zeros. But this one is an even number, so it's going to bounce off this one. So I'm going to try to pull all that together. And I say, okay, well, if it passes through, x -1, you guys probably saw that. It's going to bounce off here. It's not going to go through. That would be a mistake. So it's going to go down, and it's going to come up. Now it's got to come back to this 0. And what does it do? It passes through that 0. So it's going to come back through here and pass through. And notice, what does it do at -4? Because of that 1, it passes through. So I'm getting a very poor sketch. Now we got to get more accurate. Give me a second. Okay, grand finale of the pre-lesson. So, how do we find out how accurate our yucky sketch is? Well, this is 0 and this is 1, so I got to plug in 0.5. That's why I put a 0.5 in right there. And I plugged it in here and here and here. And I did the math, and I got 0.14. So that means this barely gets above the x-axis, so we were way off. Then I plugged in -2, because that's the halfway point from 0 to -4. I'm plugging in x as -2. And I did the math, and I got a really, really low number. We're not going to be able to fit this on here. So I'll just go way down here and then up. So probably that one's not accurate. It probably goes up like that. And good drawing? No. Get the general idea? Yes. If they asked you what's this turning point, you should be able to say -2, -324. What's that turning point? That'd be 0.5, comma, 0.14 up. There it is. Don't skip those example problem videos. Those are going to really help you out a lot.